2.4D, I'm just going to do a couple of problems. We're just going to be looking for the critical point. Some examples. As I said, in this homework, you're going to be using a little bit more complicated equations. Not difficult, just you've graduated. Let's put it that way. So let g of x equal x e to the 2x. Okay? Now, if we're supposed to find the critical points, to find the critical points, we first have to find the critical numbers. Okay, to find the critical numbers, we need to take the derivative. To take the derivative, we're going to have to use the product rule. So I'm going to call this f, call this g, and we're going to use the product rule. Okay, the product rule. We're going to leave f the same, take the derivative of g, which is e to the 2x, take the derivative of the exponent, times 2, plus take the derivative of f times g, e to the 2x. So let's simplify. This is 2x, e to the 2x, plus e to the 2x. Okay, now I'm going to go ahead and factor, take out e to the 2x, and we have 2x plus 1. Now, why did I factor? Because what we're supposed to do is set this equal to 0 to find the critical numbers. So setting this to 0, we have 0 equals e to the 2x times 2x plus 1. Okay. Now, so we have e to the 2x equals 0, or we have 2x plus 1 equals 0. Now let's think about this. Can we put any possible number in x so that we get 0? If we put a 0 in there, we're going to get 1, right? If we put a negative number, we're going to get another number. That's not 0. We put a positive number, we're not going to get 0. So this will never work. We will never get 0 there. Now how about here? We have 2x equals negative 1, x equals negative 1/2. Okay, so what do we find? This is our critical number. Now what are we going to do with this critical number? We want to find the critical point. So we go to our original function and we find g of negative 1/2. Okay, and when we put 1/2 into that equation, I guess I'll go ahead and do it for you. We have negative 1/2, there you go, e to the 2 times negative 1/2, and that's negative 1/2. This becomes negative 1, which is just going to be e to the negative 1, okay? And that's going to equal negative 1 over 2e, bringing that e down. So our critical point now is going to be, our input was negative 1/2, our output was negative 1 over 2 times e. All right, now let's do another one that may be a little bit tricky. Now, not difficult once again, but notice the wording in this question, okay? So this is our last question for today. Determine the critical numbers. Determine the critical numbers on the interval from 1 to 6. Now remember, those are our x values, our interval from 1 to 6, for f of x equals x plus 9 over x. F of x equals x plus 9 over x. Now notice x can't equal 0, but it doesn't matter because we're looking on the interval from 1 to 6. Okay, so let's take the derivative of this. Taking the derivative of x is 1, okay? Taking the derivative, 9 over x, we can use the quotient rule. Derivative of the first is 0 times the second minus the first times the derivative of the second, all over the second squared. So what do we have? We have 1 minus 9 over x squared. Okay, now we did this because we want to find the critical numbers, so we have to set f prime of x equal to 0. So we have 0 equals 1 minus 9 over x squared. Okay, so what can we do next? Anybody have an idea? Well, how about this negative we put over here? 9 over x squared equals 1. Okay, now if we multiply both sides by x squared, we're going to get 9 equals x squared. I just multiplied the left by x squared, the right by x squared, and we have x squared equals 9. Square rooting both sides, we have x equals plus or minus square root of 9, which equals plus or minus 3. Okay, but we have a problem. We have x equals 3 and x equals negative 3. Here's the tricky part. Determine the critical numbers on the interval from 1 to 6. Negative 3 is not in the interval 1 to 6, so we don't even consider that. So our answer is going to be, that just means therefore in math, the critical number on the interval 1 to 6 is 3.